Hello everyone, welcome back to Stat 385. In this video, we are going to go over a practice exam. So I'm in PrairieLearn right now. Just to go over to my screen right here, you can see that I have my setup that I like with our studio. Here, notice that I've configured around the 4 panels. Most notably, I moved console over here, in which case, I can already see that my face is going to be in the way. Okay. So I'm gonna move that up. Okay, so I have my R script here and my console here, and I put down the global environment and so that I have maximal space to work. Okay. And now just to full screen this, I'm on PrairieLearn, and we're gonna go through practice exam. I'm gonna create a new instance. You can see that, I should say that if you have not already created an instance in the practice exam and worked through it, then you should stop this video and go do that, because otherwise watching me doing it and going through it are two completely different things, and you'll enter the exam with a false sense of confidence having seen me go through this. Since I haven't taught this course before, you can see that I have some practice exam instances where I've been trying to play around with some things and get my hands dirty with it so that I can build some comfortability with how this actually works. So we're going to create a new instance. You can see that there's this screen right here, which will alert us that we have 110 minutes, exam 1, stat 385, all good. I certify that I am allowed to take this assessment. Pledge my honor that I won't cheat. Okay, great. Not going to do those things. Okay, so presumably you've read the exam policy. If you haven't done it, you need to read it word for word. That'll be very helpful. Question 1 about the exam. Before completing the exam, be sure to read the exam policy, which you have done before this video and before the exam. You're not going to just not read that, because that would not be good. On the course website. Okay, so all of these following. So I'm in the exam. I get anxious too about time. I can already see that I have time remaining 109 minutes. It started at 110. I think that will be okay. So you should think about. I've created the time window based on how long it takes an instructor to code it, and then I have like a multiplier, and so there should time should not be of too much concern, or hopefully, and if it is a concern, then what you're going to want to do is figure out ways to maybe game the auto grader and try to guess at like what kinds of outputs will be needed from like functions, say for instance, in order to try to pick up as much partial credit as possible. Okay, anyways, before getting into all that, okay, so this is just free points. Okay, so I will not communicate with anyone except the proctor during the exam. If I communicate with anyone during the exam, I will receive an automatic integrity violation and receive a score of 0. So don't want to do that. I will not use any materials that are not allowed on the exam. You can see it on the exam policy document, but basically what you're going to want to do is restrict your attention to RR Studio and the course website and materials linked in it. So you can use your textbook, you can watch the videos, that kind of stuff. You probably won't want to watch the videos on the exam because that's going to be tedious and take up too much time. I would not ask for a curve. You don't really want a curve, I don't think. This class is doing really well, so a curve would take the course that's doing really well and then like make your grades not do really well. So you don't want that. I will not. Okay, David should be Daniel, but that's okay. I will not discuss this exam. Don't discuss it because there's various conflicts and different scheduling things that have happened with students, and so I don't want there to be this like, oh, here are the questions that are on the exam just kind of floating around in the ether when people are yet to take it. So I will be the person who knows when everybody's done, and then I can tell you that you can discuss the exam. I have read and understood the exam policies. Yes, and okay. Save and grade. Here we go. Great. Got some points. Feeling good. Okay. go back here. So I have 5, so I kind of have to get these ones right. Okay, so now, which of the following creates a double vector? No, I don't think so. No, 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 because I think this is integer, and then that is going to get coerced to integer, I think. False 1, yes. Character, no, no. I believe so. Sequence, I wonder if this automatically does it to integer. In any event, I can try it out. Okay. Double false is dot double. Okay. I'm just going to demonstrate that we still have enough time even if we type these out to double check. But if you use from the class the keyboard shortcuts that I've introduced, then that will save you some time. Okay, good. As is dot double false is dot double false is dot double true. Yep. Is dot double. Remember that there's different types of NA values. True. Okay, I wasn't 100% sure. This one, if the previous one is, then this would have to be, right? Yeah. Okay. I think I got them all. Okay. And then what I'm going to do is I'm just going to create a new script and just clear it out. I don't want any clutter on the screen when I'm working here. Okay. Question, so checkbox questions. Kind of makes sense that there'd be only one attempt at these. Which one will return a length 1 logical vector containing true? This won't be length 1 because it's gonna, no, don't do that. I don't think so. All, no. Man, I'm not 100% sure on that one either. Any 5 greater than this. 5 greater than that sequence. Any. Yeah, I think so. True and false. No. This is going to get, I think NA overrides. Not true. That needs, yeah, it would be great if R did stuff like this and kind of just evaluated multiple logical expressions at the same time, but I think what's actually going to happen is going to be an error. A in this, R is case sensitive, any. I believe that would work, and I don't think so because that needs to be split up. Not too many trues. Unless I'm, horribly mistaken on some of these, which I've already seen that I'm not perfect. Okay, definitely not length 1. False, false, false. Any true, true and false, false. True equals NA, NA, not true, false, error, case sensitive, true, and false. Okay, and because I'm absolutely paranoid, I'm gonna check. Okay, 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3, 4. Wait a second. 2, 3, 4, 5, 6, 7, 8. 10, 11. Okay. Looks like yeah. These checkbox questions I always have a little bit of anxiety with those types of questions, but they are not actually all that hard, are they? Okay, question number 4. assume the following code has been run and objects named X, Y, and Z. Oh wait, that's right. I'm going to just create a new script. Are in the global environment. Okay, well, I know that they aren't. So we're going to first do that, run it. Now we're going to have some sort of which of the following returns a list. Okay, so we want preserving versus non-preserving subsets. So Y1, I believe that's true. X is atomic vector. Logical length equals X5. That's going to create an atomic vector. Z1, I believe this breaks. Okay, that's going to be, I think it's an atomic vector. I think that this preserves the, even though we're doing empty subsetting, it's not going to return anything useful. I think that it returns the attributes. YEC, looks like a list. YA, XFOO, that's an error. And YC52, that's a list. Okay, did I get all these? Okay, first one, atomic, list, atomic, atomic. Wait, what am I doing? Why would I do, I want to do, even though I can read those ones. Yeah, Z1 is dot list, is dot list. See, false, true, yeah, is dot list, right, false, the logical thing, false, true, true, okay, is dot list, is dot list, false, wait, yeah, okay. That's what I thought. Is dot list. Oh. Yikes, turns out I'm not the best with this either sometimes. Okay. So now basic coding questions. Let's get a new script, clear this. Okay, write a function, name only lit. Okay, so let's just follow the tasks. Okay, takes on X. Okay, and we want to get out of this. So our function takes a list with some number of elements. The function to return a list that is a subset of the original list with all non-list elements removed. Okay, so probably going to use this is.list function. And let's just get to our cases here. Okay, so you can see here that this list has elements which are lists and elements which aren't. Okay, so that's, if you need extra clarification, look at what the example is. Okay, so we want to just pull out the pull out just the elements that are lists. So what we want to do is lapply is.list. So we want to apply that element-wise to the elements of the list. Okay. However, I can use that in subsetting. I want this to be, I want the actual vector. Oops. What did I do? I'm being silly. Not a function. Okay. That looks like the right output. Great. So I need to put that into our function, remembering that the argument name is X for our function, and that was our example. So try it. Looks good. Wait, what was I supposed to do with this? Oh yeah, submission. Okay, delete that. Save and grade. 5 attempts left. Whew, there we go. Okay, so question 90. Okay, consider a sequence. Consider the following sequence. Let's make sure I close everything. Create an atomic vector named fractions. That stores the first 122 numbers of the sequence using a decimal representation. So that's that sequence right there. It's not going to write it out in fraction form. It's going to be a decimal representation. I'm pretty sure that's just 1 divided by 122. Well, they can't all be hard questions. Or else that would be no fun. I don't know these off the top of my head, but it looks good. Okay, so fractions. Put it in. Okay, there we go. Please. Yep. Okay. Question 7. And clear it. In many Olympic events, scoring is based on the average of judges' scores. However, before the average is done, the highest and lowest score will be removed. For example, considering the following judge scores. Okay. In this case, 9.9 and 5.6 will be removed before averaging, so the final score will be the average of these numbers. If there are ties for highest or lowest, only one of the scores is removed, right? Okay, so yeah, sort function is going to be useful. Okay, so write a function called calc_Olympic score, which takes on one argument called judges score. Okay. So what we want to do is something like sort. Let's get. Okay, so I want to get equal C 8.7, 9.9, 5.6, 8.4, 7.3, 5.6. Okay, looks good. So now I want to sort it. And that's going to isolate the minimum and the maximum. We'll call that Y. And we'll get Y C1 length Y, right? Because this will get the numbers 1 and n. Wait, what? Oh, I must have done. Okay, 1 and n. 1 and 6, okay. And now, but I don't want those ones. I want those ones removed, so I need to do negative subsetting. Okay, so that looks pretty good, and then I need to do mean on top of it. Okay, looks good. So let's put this in here. Sorry to have paused it and rejoined. I had heard some background noise that was starting to bother me, and I think it's just somebody like hammering or something on a wall in a distant unit in my apartment building. Anyways, okay, so calc_Olympic score. So I have an intermediary quantity vector where I sort the judges' scores, and I do some negative subsetting for the minimum after doing the sort and the endpoint removed, and then take the mean. And I want to check if this works on this vector. Okay, I get the same thing. Technically, I should specify it. Okay, looks good. So let's copy that in. Nice. Okay, Question 8. Create a list named SumList. What are we going to be doing? A double vector, which contains the value 42. A character vector, which contains the value exams are fun. Are they though? And an atomic vector named D that contains the integer 7 to 120. I mean, I believe that this is right, yeah. 42, exams are fun. Atomic vector, 7 to 120. Okay, D, V, F, looks good. Okay. Nice. Okay, we have 90 minutes to go. I'm feeling pretty good about the time, although the questions will get a little bit harder, right? Okay, write a function named odd or even odd rows. And it takes on two arguments, x and odd, which is a logical vector of length 1 with default value equals true. Okay. So you can kind of see by the wording of this that there's going to be some partial credit on just getting these things right. The function should return a data frame if odd is true. If odd is true, the data frame should be a data frame containing the odd rows, the input data frame. And false should do the opposite, should do the even rows. Okay, we have a nice data frame here to test on. Okay. Okay, X is a data frame with at least 2 rows. Okay, because they want to probably return something that's useful based on this odd argument. But that's nonetheless good to know. Okay, so what are we going to do? So there's many ways that we could go about doing this. You could think of, some sort of like integer, isolate the even and odd numbers based on the number of rows and stuff like that. These are all perfectly valid, but let's try something like using using some recycling. Okay, so if odd is true, we want the odd rows. So this should just recycle. So if there's like 7 rows, then this would get true, false, true, false, true, false, true. Okay. So this would be okay. So then this would be even. Okay. So let's see what happens. That gets odd, that gets even. Looks good. So then what do we want to do here? No. Let's see here. Yeah, so if odd, do this, then return that. And return just to make sure. Okay. Actually, you know what? I don't like that I edited in the thing. Let's say we have this odd equals true if odd, just to see what we get here. Print. Yeah, okay. So we can kind of see that this is gonna work here. And then so the idea being that this if statement, I could do, if else and that kind of thing, and it might make sense to you to do something like that. But if this condition is satisfied, this is just going to like return the value and end the function, won't touch this line. So if this condition is not satisfied, then it just returns this thing. Okay, great. Now, what do I want to do? So I have my function. I want to try it out on x equals xdf. Okay, so that's odd. Sorry, no, it's not odd. It's working. That's for odd is equal to true. Okay, so it looks like it works. Okay. Nice. So it's a little bit hacky at it. Okay. New script. Okay, I'm just gonna restart R. Okay. Just want to make sure we're all good to go. Create a data frame. Name sumdf. That has 37 rows and 3 columns. Well, the columns are going to be, it's very specific. Okay, so why is it so specific? Okay, so you see what happens here if you were sort of clued into that. It's weird that it's 37 rows. Probably one of these is going to be something that is length 37, and the first thing was not that, so it's going to get there's going to be length coercion and recycling, that kind of stuff. And if you look at the last element of the data frame, you can see that there is an atomic vector containing the integers from 1 to 37. So we know that there's going to be length coercion. Okay, so I can just specify this. B equals, okay, I know I can spell stat385, but since I only have finite number of checks and it's exam mode, I just want to copy it in 1 to 37. Let's try it out. Yep, we get the desired length coercion. Okay, so then I need to dbx. Okay. All right. So you can see, I haven't been lingering on this, but you can see right here. Okay, is the code free of illegal functions, code, and packages? Does the code run without errors? Is the created object a data frame? So like you could just do like data.frame and put anything in here, and then you would get like 3 of these points. And if you did something like just this, now it looks like we're looking at 4 points. Correct names. So you want to get that one if you did this. Number of columns. Yeah, so like if you just put in gibberish for the other columns, then if it had the correct number of columns, you're already getting the majority of the points by not even answering the question. So if you were running out of time, this question was actually pretty easy. Bad example would demonstrate the point, but you can see how this is can be gamed if you're in a crunch. Okay. So we're done with basic coding. How am I doing? 82 minutes to go. I think that this is going to happen. Okay. So question 11, selection sort. Oh, that sounds fun. Function value x. Okay. The function will return a numeric vector with the same length as x. See, again, you can see these words where all the partial credit is. Containing the same elements as x, but sorted. I wonder what happens if I just, okay. So what happens if I just do this? Do you have it? Okay. Let's see what happens. This is, I don't want to not get full points on this demonstration video by trying it, but I am very curious. 4 out of 10. Shoot. But I got 4 out of 10 points. I didn't do anything. If you wanted to get, if you were like right at the last question and you wanted to get a 94, then you just got it. Okay. Okay, let's be serious people doing serious things now. Okay. Okay, so then what do I want to do with this? So the function should return a numeric vector with the same length as x, containing the same elements as x, but sorted, that is, arranged in increasing order from least to greatest. Okay, so create a new empty vector, say y equals double length x equals length x. Okay. Oh wait, yeah, I should probably get, I'm gonna just take this vector right out. Okay. Just to make sure. Okay, looks good. Okay, so create new vector, say y that has the same length as x. Empty here likely means that some value, for example, 0 could be used. Okay, find the smallest element of x, place this element in the first empty element of y, remove this element from x. If there are ties for the smallest, we suggest only moving and removing one at a time, but it's possible to do them all at once. If x still has elements, return to step 2, return y. So there's this nice little hint, this which.min function. Be pretty useful, I think. Okay, so which.min, you can see from the example what it's doing. We have a vector of length 5, and it finds the first occurrence of the smallest element in that vector and isolates the index. Okay, so there are many ways to do it, but the expected solution uses a for or while loop. So much ranting and rambling about not using for loops. However, this is very natural for this question, so yes, that makes sense. Okay, for I in sequence along x, right? Because our argument name is x. Okay, why did I do that? Silly. Y I equals x which dot min. Is that right? And then x equals x okay, find the index, that's the minimum, and take it out. I think that's right. Let's see what happens. Okay, so y is nothing. Now y is something. Well, I think that looks pretty good. X is nothing. Okay. Let's try it out. Return y. So, okay, sorry. I kind of coded it and didn't really explain too much. So let's see here. So I have my for loop, which I don't want to get into messing with doing 1 to the length of the vector. Sequence along, it gives me the integers from 1 to, you know, the length. So that does that automatically. And then what did I do in this for loop? Oh, wait, I'm missing something. Oh my goodness, I'm so glad that I stopped. Okay, so I create this intermediary vector, which is sort of this empty vector of the same length as x. And now the first element of that vector will get the lowest element, the smallest element of x, because I'm using this which min function to isolate the index of the smallest element of x and then just pulling it out. Okay. And then I want to, once I have that element and assigned properly to y, then I want to remove it from x. I don't want to repeat the task and just have it just go 1, 1, 1, 1, 1, 1, 1. That would be not good. Okay, so I have my function. I'm pretty happy with it, but being happy with it and testing it and making sure are two different things. Okay, so that one worked, which we already sort of knew it would. Okay, so this should just return 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. I want to just pause really quick because I just burned one of my attempts trying to demonstrate some point about how to game the autograder and get 4 out of 10. But now I want 10 out of 10. Okay, so making sure, you know what? I have time. So I'm going to just clear all that. Okay. Looks good. I wanted to be absolutely sure. So, okay, took a little bit of time there. Okay, so great. 74 minutes. And oof, a lot going on here. Okay, so if you want to, you can pause and read the instructions here. Okay, so I want a function split int. Okay, it's going to take on a numeric vector of length 1 that contains a positive integer that is at least 2 digits. The function should return an integer vector. It has to be an integer vector with a length equal to the number of digits of the input number. So if it's 314, it's going to be length 3. With each digit of the input vector, as an element of the return vector. Okay, so C314. We recommend the following strategy. Coerce the input to a character string. Use the string split function to split the input into a vector containing the individual digits. Coerce this new vector to an integer. So as.character string split as.integer. Okay, and then we have another function to write. Okay, so here you can already see that, well, I'm gonna get partial credit for doing this one, correct? Okay, so let's just come up with something. 31415. All right, so coerce this to character as not character x. Okay, that did something. str split. Oh, you know what? I know. There's this little split. Yeah, we saw that in class. So we need to specify an argument here. Split equals, I think that's what we needed. Yeah. Silly, silly, silly. Got to be careful. Okay, make sure that I had this so my face was still able to be seen and it doesn't cover up the code. Okay. So that's creating a list. Coerce this new vector to an integer. I don't like that's a list. Okay. And then coerce it to an integer. As dot integer. Okay. Well, that seems to work. Split ints equals 415. Okay. Just to not do that. Okay, looks good. Okay, so we got one piece of the puzzle done. I'm happy with my split int function. Clear it. Okay. Now we need a new function. Is valid equals function with arguments cc. Okay. The function should return a length 1 logical vector containing true if the input number is valid and false otherwise. So we're going to have to determine if something is valid, hence the name of the function. But you could see here, so again, this is one of those things where if you just put in return true, and then you were to submit both these things, I think you'd be into getting some partial credit here. Maybe even a lot of partial credit. So, but we're serious people who want to do serious things, so we're not going to do that again. Okay, so the function should return, okay, so if something's value, use the following implementation of the Lun algorithm. Great, there's some detail on it. I really enjoy learning as much as I can get my hands on, but in the interest of time, I am just not going to learn the details behind the Lun algorithm. I'm going to assume that somebody named Lun had worked on it. So we got some lecture logic to get that correct. Okay, anyways, start with positive integer. Okay, so the function should return a length 1. The input is one logical vector containing true if the input number is valid, false if not. Okay, so we're going to start with a positive integer with 2 or more digits. A numeric vector of length 1 that contains a non-negative. Okay, so then we already sort of know that we're start with a positive integer with length 2 or more digits. Split this number into a vector that contains the individual digits. Okay, so I'm just going to follow along with this example. All right, so the idea here, so we can see that what we just did is already incredibly useful. Okay, so cc equals this. I don't want to do y equals string split y. Okay, so now I have this. Remove and store the last digit. This is called the check digit. Okay. So I'm going to just call that check digit equals y length y. And let's do these. Let's display them as we go. Okay. Okay, so far so good. With the remaining digits, start from the rightmost last digit, moving left double the value of every other digit. Okay. And okay, so with the remaining digits, so z equals y minus length y no, I wanted to do z here, sorry, z. Okay, so I want to, okay, so every other digit, starting with the last one. So first, okay, so I can think in terms of a for loop which would do this. If I think of an apply function, seems like it's going to work element wise. It kind of loses track of which index you're currently in. So, man, okay. So let's see here. If I do for I in sequence along z, all right. So I want to z, you know what? I don't think I want to do sequence along. I think in this case I want to actually do length z to 1. Just make sure. 4, 3, 2, 1. Then z I equals 2 times. Oh boy. Okay, so that's not gonna double the value of every other digit, including the right. So the remaining digits starting from the rightmost last, moving left. You know what? Let's see here. I don't like that actually. Okay, do you like that? Okay. Let's see. If length z is, if there's an even number, then what I want to do, C false, true. Yeah, this is what I want. Okay. And then so basically what I'm doing is if it's even, then I'm extracting the even elements, multiplying them by 2, and that has the effect of starting with the rightmost, multiplying by 2, skipping, then multiplying by 2, and then if it's odd, it's going to be the opposite. So I want true, false, true, false. Okay. Wow. All right. Start. Okay. Split, check digit, remove check digit, this thing, we get that. Okay, looks good. That's what we got here. Replace the resulting value at each position with the sum of the digits of the position's value. Interesting. So I think the way, so this 18 and this 16 here, I think I could just call split int on it, split int on a length one in, or sorry, an integer vector with only one integer, just like 4 or something. Then if I run the split, let's see what happens. Split int 3, just 3. Okay, so then this one, nice. L apply z split int. Okay, now check this out. I can L apply on top of that sum 4917. Okay, that one. Okay, so I get that. We'll call it, why did I start with YZ? Now I'm already, okay, well, it's not gonna be pretty. Foo, we'll go back to our friends. Okay, foo. Okay, so let's just start again. Y 49189, check digit is 9. Z, actually, you know what? I wanna make sure I'm getting rid of it. Z 41816, foo 4917. That's where I'm at. Sum up the resulting values from all positives. Call this sum S. S equals sum foo. Okay. S equals 21. If this is equal to the check digit, the number is valued. Oh, what do you know? Equals check digit. That is fascinating. Just want to make sure that we put that in parentheses. I think that's what we're going to return, right? The number is valid. Okay. Interesting question. All right, fun. Slow down, because I got time, right? Yeah, so split int, let's just go through it. 49189, check digit 9, remove check digit, and then multiply number, start with the right one, multiply by 2, skip, then multiply by 2, so forth and so on. Okay. Then this nested apply thing where we apply our split int function to each one of the elements of Z and then sum them. And sum all that and then run this thing. Okay. That's our function. Okay. So okay. Don't need this anymore. Don't need that. Don't need that. Okay. Don't need this. Okay, technically the last thing will be returned. Okay. Is valid. CC equals 49189. True. What happens if I do this? 491892. Check digit is 2. I remove 2. Okay, this is what I wanted to check. 18 is double of 9. 2 is double of 1, and 8 is double of 4. Okay, so that worked. Okay, 9, 2, 8, yeah. 36. Okay. All right, I think this function is, I think it's good to go. Oh, wait, okay. Oh, geez. Be careful. What's it say? On demonstrates usage of both functions. Let's try the cases. Split int. 49189, true. Oh, what did I do? Split int is valid. Okay. Yeah. Same attempts. All right. Well, that is the exam. Definitely hard to talk about it and code in real time. You could see some of the things that I do to write it. You can see that I'm, it wasn't even me taking it. It's not perfect, right? Like I had to spend some time hacking at some stuff and until it kind of clicked what needs to be done with that, especially with that last question. And then throughout this video, I showed or emphasized that, there's ways to, think about how to get as many points as possible in sort of a time crunch. And if we go back to that last question here, what was I going to say? If you write, this function was pretty easy, relatively. If you were to come up with a correct version of that function and then do this thing with just the correct argument name and then returning just true, you're probably going to get a lot of, what were the points? It's code free of illegal functions, code impact. Okay, run without errors, yes. Does the split function work correctly? Does the split function work correctly? Okay, so then you're getting points on just this split int function. So that's 4. How many are there? 9? Oh, yeah. And then validity function, well, one of these works on true. So that's 1, 2, 3, 4. You may get a random one correct on the validity function. So just by doing something, you could get 5, 6 out of the 9 points just by putting something down. So if you're in a time crunch on a hard question, then that's what you can do. Here, I wasn't in a time crunch. Okay, well, anyways, I'm starting to ramble. If you watched this video, thank you for your attention and good luck on the exam. I hope that this is helpful. I hope that you at least started a practice exam before watching this video, just to kind of get comfortable on your own and with how this is going to work. And I hope that this video helps. All right, take care. Bye.